Welcome to Electronics Unmessed. Here is Klaus with another episode of our user's guide for our thermal insulation Excel tool. Today we predict the contribution of waste heat from electrical devices to the heating and air conditioning of our house. We will see how we can even benefit from it. We saw in the last video that the sun can have a really big impact on a home's energy consumption. I link you to the video in the top right. And if you make clever use of it, you can even save a lot of money. We can even predict that with our tool. There is similar effects with the waste heat from electrical devices that we use in the home. Whether it is lighting, computers, televisions, washing machines, refrigerators, all of these devices consume electrical energy. In operation, they emit almost the same amount of waste heat as they draw electrical power from the socket. Today, we will see how we can model this in our Excel tool in order to calculate the impact on the total heating energy consumption per year. By the way, you won't miss the next episode if you subscribe and push the bell. We go to the sheet Electricity. Similar to other inputs, we use the monthly average values for the electricity consumption during night and day. That's precise enough to calculate heat flows because they have rather long time constants. What I mean by that is the following. A building stores heat energy for hours. Therefore, it makes no sense to consider the actual changes of the electrical power consumption. And the average values are sufficient because the volatility is averaged anyway. I have already entered the electricity consumption here as an example. You get this power consumption when 2 to 3 people live in the house on each floor. During the night, I entered the standby power consumption since everyone in our house sleeps at night. On each floor, we draw a constant power of about 30 watts. In the basement, we have a freezer that consumes about 40 watt on average. During the day, the electricity consumption is different because then the electric devices are in use. During the winter, we typically need a little more electricity than in summer because we spend more time indoors and of course we need more lighting. I have roughly mapped this in the monthly consumption values. 3 people live on the ground floor and 2 people live on each of the 2 upper floors. Okay, not everyone can measure these average values and there is actually no need to do that. We estimate it using the data that we know. At the bottom, we get the sum values for a cross-check. We see the consumption for the whole year for each floor per month and for the whole house. You can compare the annual consumption directly with your electricity bill. Advanced energy suppliers that use smart meters can also provide you with your real monthly consumption. In our example, the total electricity consumption of the house is 8,785 kilowatt hours per year. With 7 people living in the house, the electricity consumption per person is 1,255 kilowatt hours per year. This roughly corresponds to the average in Germany. But beware when cross-checking the total consumption. For our waste heat calculations, only include the electricity that is consumed in the house. So you must not consider the consumption of the electric car or the pool heating. And you know, this tool is to predict the energy for heating or air conditioning. We must not consider it for the waste heat calculation either. Okay, now let's assume that we have correctly estimated and verified our electrical power consumption. And then we can actually forecast how the waste heat from electricity consumption affects our cost for heating and air conditioning in the house. For our calculations, we can switch the influence of electrical power consumption on and off. And we are doing that right now. We have a total consumption of 120.8 kilowatt hours per square meter per year without considering electricity. Most of the energy is for heating, namely 120.1 kilowatt hours, which is typical for our climate in Germany. We only need 0.7 kilowatt hours per square meter for air conditioning. If we want to take into account the waste heat from our electrical devices, then we simply turn it on here. And then our heating energy consumption drops to 104.8 kilowatt hours. However, the energy consumption for air conditioning increases from 0.7 to 3.7 kilowatt hours. These are the totals for the entire house. Now let's take a look at the details in the energy performance report. Obviously, the air conditioning concerns the upper two floors only. We actually need 5.3 and 5.4 kilowatt hours per square meter there for air conditioning. From the prediction of our tool, air conditioning would be desirable to have convenient temperatures, but it is not an absolute must-have. And it is actually the experience that we have at my location during the hot summer days. Okay, but what can we do with this calculation now? Well, we can include the influence of waste heat from electrical devices in our overall planning. Just as an example, a home office with moderate power consumption would be better placed on the ground floor than on the top floor. You can already derive that from the predicted data. Maybe you have other ideas for scenarios to compare? Write me in the comments. In general, if you have any questions, always in the comments. I will be happy to answer that. That was the 8th part of our step-by-step user's guide. Yes, waste heat plays a role, and we can take it into account in our simulations. There are still some more functions in our Excel tool that I need to explain to you in the coming episodes. We need to talk about the impact of people, the cost calculation and the tariffs. Later, I want to give you a few more tips on how to get even more interesting data out of the tool. Now, stay tuned and don't forget to support the channel. See you soon in the coming episodes.